Okay, so let's continue with our second example. So we've got a rational expression here, we've got a rational expression here, and we want to subtract the two. However, we need to make sure that they have a common denominator. But first we need to factor each of these denominators, state the non-permissible values, and then of course then find a common denominator. Okay, so we look at this denominator, x squared plus x minus 6. And so we can just factor that accordingly, right? This is just going to be x plus 3 times x minus 2, okay? And then we factor the denominator of the second expression. And so it's just going to be x plus 1 times x plus 3, okay? And so we look at this. Let's make that look more like a 3. There we go. So we look at the first expression and we go, okay, what are the values of x that would result in this being equal to 0? Because that would, of course, give us a non-permissible value, right? So if x is equal to -3, that's going to present us with a problem. So we're going to list that as our first non-permissible value. If we look over here, if x is equal to 2, then yes, then the denominator will be equal to 0. So x cannot be equal to 2. And then on the right, we look at the denominator here. X cannot be equal to -3, but we've already listed that, okay? And x cannot be equal to -1, okay? So we've just stated the values that that x is not allowed to take on, okay? Next step, we need to find the a common denominator. It could be the lowest common denominator or just any common denominator in general. So first of all, we look at the factors here. We've got x plus 3 here, and we've got an x plus 3 over here, so that's fine. We see in this denominator we have x minus 2, but in this denominator we have x plus 1, not x minus 2. So I'm going to have to take this expression, I'm going to have to take the numerator and denominator and multiply it by the factor that is absent. So I'm going to have to take x minus 1 over x plus 3 times x minus 2. I'm going to have to multiply the numerator and the denominator by, of course, x plus 1 over x plus 1. There we go. And then, of course, for the second expression, we see, yes, we've got x plus 3, but we don't have x minus 2, so we're going to have to multiply the numerator and denominator by that. So minus x minus 2 over x plus 1 times x plus 3 times x minus 2 over x minus 2, right? And so now we've got our common denominator, right? So really, this is just a matter of multiplying everything out. So x minus 1 times x plus 1. This will produce, these are, of course, conjugates, so it's going to produce a difference of squares. So we will have x squared minus 1, okay? Minus, okay, if we do x minus 2 times x minus 2, that is, of course, going to give us a perfect square trinomial. So we'll have x squared minus 4x plus 4, and again, this is over our common denominator, so it's going to be x plus 3 times x minus 2 times x plus 1. And we don't have to worry about multiplying this out. We're not expected to do that, although that wouldn't be too difficult anyway. All we need to do is simplify, okay? So if we've got x squared minus 1 and we're subtracting this this quadratic expression over here, all we have to do is distribute, right? We're going to get x squared minus 1 minus x squared minus minus, right? A double negative, so this will give us plus 4x. And then if we subtract 4, right, we get negative 4 there, all over our common denominator, all right? And then, so all we have to do is simplify, right? So we've got this here, we've got positive 1x squared, we've got negative 1x squared, so they're going to cancel out. We've got negative 1 here, and we've got a negative 4 here, so it's just going to be negative 5, right? So we're going to have 4x minus 5 all over our common denominator, well, minus 2, x plus 1, right? Let's make that look a bit, yeah, there we go. Now we can't cancel anything out. If we had x plus 3, x minus 2, or x plus 1 up here, we could cancel things out, but we just have 4x minus 5. We can't possibly factor this or do anything, so we're all done here.